In this video, we're going to look at Hess's law problems in which you find nothing unique. So let's look at problem number 10 here. On problem number 10, C2H5, there's a C2H5 there, C2H2, that looks unique. H2, there's an H2 there, so that's not unique. O2, there's an O2, there's water, water. So it looks like there's something unique in equation 1 and equation 3. But equation 2, that one right there, there is nothing unique. So let's take a look at how we're going to handle this. Let's first deal with the two equations in which there was something unique and decide what we're going to do with them. When we compare the first equation, so this one right here, we're going to compare specifically the unique thing with the target equation that we've been given, which is right here. We can see that C2H2 is actually on the reactant side, not the product side. But there are the right number of them. So we need to multiply number 1 by -1. Number 2, there's nothing unique, so we're going to have to deal with that one in a minute. Number 3, the two CO2s look like in the target equation, we do have two CO2s, so we have the right number of them, but the two CO2s are on the product side, not the reactant side. So again, we're going to have to flip that equation. So we're going to multiply that last equation by -1. Once we know what we need to multiply the equations by, we need to go ahead and carry out those operations. So -1 means flip the equation. So that's going to be C2H2 plus 2H2. The products become the reactants, and the reactant becomes the products. We're going to do the same thing here with this third equation. So C2H6 plus 7 halves O2, and then the products, or the reactants, are now the products, so that's 2 CO2 plus 3 H2O. Once we've actually carried out the operation on the reactions, we need to add these reactions together. So on the reactant side, actually right away I can see that I'm going to have C2H6 on the reactant side and C2H6 on the product side. So let's go ahead and get rid of that right now. So we're getting rid of that. I think that's the only thing that we can simplify. Now let's go ahead and add these equations. On the left side, we're going to have C2H2 plus 2H2 plus 7 halves O2, and then arrow. Now let's go ahead and put on the products, 2 CO2 plus 3 H2O. So right here we've added the two equations that we knew what to do with. Now we need to compare this to the target equation and see if there's anything in here that doesn't belong. I can see something already. I have 2H2 here, but you'll notice in the target equation I don't have any H2 anywhere. So we need to get rid of that, and that's what we're going to use the nothing unique equation for. In order to get 2 hydrogen on the product side, we need to multiply this second equation by -2. And doing that is going to give us 2H2 going to 2H2 plus 1O2. And you can see now that we did that, these 2H2 and those 2H2 are going to end up canceling each other out, which is going to give us what we want in the product. So now that we've decided what we needed to do with that nothing unique equation, we can go ahead and carry out those operations and multiply this through and then add them together. Negative 1 times 283.5 is negative 283.5. Negative 2 times negative 213.7 is a positive 427.4. And then 849 times negative 1 is negative 849. Now we're going to add these values together. And when we do that, we get negative 705.1 kilojoules. And you can see the answer up here, or down here, is negative 705 kilojoules. And they probably rounded, so I think we're okay. So that's what you do anytime you have something that's not unique in an equation.